any time more before we, so there's some people that miss the session. Yeah. I mean, whenever we start and we are not recording, you can just just speak up. Yeah. So another thing is training set and validation set. So what's the meaning of training set? So this is what we mean by training set. Now in machine learning, when you have your data set, so here we have my data set, which is, for example, 150. Now, when you want to do your machine learning, we need to train the machine learning on this data. But in machine learning, we don't train on the whole data set. We divide the data into two. The first one is called training set, and the second one is called evaluation set or test set. What is the purpose of these two? The purpose of these two is, the first one is to train your model, just for the model to learn. Now, when you train the model, the second one called test set is to test your model on this test set to see whether your model can do good prediction. So for example, the reason why we divide the two, we don't train our machine learning model on the training set, is that when we train on the whole set and we give it the whole set to learn from that, then the machine can actually remember all the data sets. So for example, you are doing, you want to test your student exams, you just teach them 1 + 1 is equal to 2. 1 + 1 equals 2. 1 + 2 equals 3. Now you teach the student this one. Now you want to test them whether they understand. Now you go to examination venue, and examination paper, you write to them 1 + 1 equals what? 1 + 2 equals what? Do you think you are testing their understanding? The same thing you teach them.
No, actually.
Not actually. The same thing you tell them, 1 + 1, you said in the class is 2. 1 + 2, you say is 3. You teach them these two things in class, and you go to examination, you want to test whether they understand. Then you give them exam 1 + 1. You ask them, what is it? 1 + 2, what is it? You teach them and you give this something. You are not testing their understanding. When you want to test their understanding, is maybe you give them what is 2 + 2? Right? If they understand the pattern there, they understand, okay, in that one, you add 1 + 1 just to give you 2. Then if you give them an exam, 2 + 2, they will understand the pattern, or 2 + 4, it gives them 6. So that is why you cannot learn from what you do training. You can only learn from what you have not trained on. That is by training set and value. We will discuss this in a bit in a detail. So the training set consists of the data used to develop the model, while test set or validation set, so we call it test set. This one is called training set, and the other is called validation set, are solely used for evaluating the performance of our final model. So this is also another terminology we need to understand. Now, there is another terminology, predictor. Independent variable, attribute, or descriptors are the data used as an input for our model equation. Now, when we want to train machine learning, here, for example, when we want to do this task, we want to train a machine learning model, give him just a flower and ask him to classify whether it is setosa or whether it's vesicular or vaginica. So, but what do we give this machine learning? We give him some stuff to learn from. This is what we give him: the sepal length, the sepal width, the petal width, the petal length, the petal. These are 4 terms, four things, observations, 4 stuff that we give it to the machine learning. And the machine learning, if we give him this, he can classify this is setosa, or whether we give him some stuff like this, he can classify this is vaginica. So this thing that we give to machine to learn, these are the thin class that we expect to machine to predict. What we give machine to learn is called predictors. So you can see here, the predictors, independent by attribute, these are the data used as input for the prediction equation. In this example, there are 4 predictors: sepal length, sepal width, sepal length. So these are predictors. What do you mean by predictors? They are the ones that will determine the model to predict. The model learns from these predictors. Now, the other one is called outcome dependent variable. Look at this, the first one is independent. The outcome dependent variable, target, class. all this refers to the outcome or quantity that is being predicted. So this what we are expecting to machine learning to give us is called independent variable, class, target. So here, if I give machine learning to learn from this are called the target predictor, and what we expect the machine learning to tell us is called class or target or some stuff like that related, or this or outcome. We can call it outcome. Any question before we continue? I got these two terms because it is important to learn to understand these terms, because they are a bit confusing when you get into the machine learning further. Any question? Feel free to ask question. This is just a discussion among us. We are just learning all together. Any question? No question? Okay. Right.
Yes, there is.
Okay.
My question is, at times, when you
hello? Hello? Okay.
Yes, can you hear me?
Yes, we can hear you.
Yes, what I'm saying is, when you read the literature at times, you'll see that some divide the data into three.
Yes.
We have the training set, we have the validation set, and we have the test set.
Yes, yes.
So I'm confused.
Okay.
Is the training, is the validation set the same as test sets, or they are different? Or it depends on the algorithm.
Right. So we'll come to that, but let me explain. So what he is asking here is that I just said that we divide our data into two: training set and validation set. That is, I said today we are doing the general stuff at the basic, but in some way we can divide our data set into called training set, test set, and validation set into three, not only two. Now, what is happening is this: when you train your model on your training set here, then we just test it on our validation set. It means when we train the model and we test it on validation set, if the model is not performing well, we go back and train the model using another maybe machine learning algorithm, or fine tune the model and try on validation set. It means we are making the machine again at the same time learning the validation set, because we train on the test set and we try the prediction on validation set, and we say, oh no, the machine learning algorithm doesn't work so well. We go back to training set and fine tune the algorithm, or select another algorithm, and now come and train the model, and now also come to validation set again. We can see that at one point, if we do this n times, it means the algorithm will learn a bit from also validation set. To avoid this problem, then we divide our data set into three: train set, test set, and validation set. Now, the train set is where we train the model. The test set is where we do the testing. We say if we train, then we test our result on test set. If it doesn't work, we go back to training set to train again and come and train. The validation set is hold until we finish everything. We don't even see validation set in this set until we finish every round of our training model. So that is what is happening. So we will discuss this more in detail in the future. In a nutshell, you can divide your data set not only in two set, train set and validation set, but you can divide your data set into train set, test set, and validation set. And the reason why we divide into two is that sometimes our model learn from the validation set when we try doing iteration. So we only divide now into train and test the training set on test set. And finally, we only, when we are ready, we see that the performance, then we test our machine finally on validation set. And the validation set is what tells us truly that your machine can work on same data. I don't know if that answers your question.
Answered, sir.
Right. Okay.
Thank
so
you.
let's go on. So So we have seen what is predictors, what is outcome. So you can see from this data set, this what we give to the machine learning are called predictors. This one is called target or class, and every row is called what? Every row is called what?
An instance.
An instance or what? Or observation, right?
Or observation, yes.
Yes. Now let's go on. Then we have what is called continuous data. And what we have what is called categorical data. We have what is called continuous data and categorical data. Now, what is the meaning of this? Now, the meaning of this is this. This, what we are trying to do here, we are trying to predict whether this flower is setosa, or it is virginica, or it is vesicular. Now, what we are doing here, our outcome here, it means the class, it means is categorical data. What we mean by categorical is that the class is nominal or attribute. We say that categorical data or otherwise called nominal attribute or discrete data take a specific value that have no scale. So for example, good, bad, red, blue, output, this example, setosa, vesicular, all these are called categorical data. So this data, which has 3 class, setosa is called categorical data. But continuous data have natural numeric scales. This data, the data for sepal length, because it's continuous, can you see it's called continuous data. It's called continuous data, which has, and it has also other stuff. So you can see this, an example of continuous data is sepal length, sepal width, petal width, or fetal width. Do we understand what the meaning of continuous and categorical data? A categorical data is something that is having a classes, good or bad. What is, for example, a student pass with class of degree. What does he pass on? First class, 2-2, second class. You can see these are classes. This is called categorical data. But when we say what is the GPA of the student, he passes with 5.1, 5.2, oh, Ashiba 5.1, 2.1, 2.3, 5.4. This is called continuous data, or even 4.0 is for continuous data. So this continuous data sometimes are called numeric. You can see that numerical or something like that. But also we have categorical data. Sometimes it's called nominal or attribute or discrete data. So you can learn from these these scenarios where we have different kind of stuff. Any question before we continue? Any question before we continue? Okay, no question. So you can see now we get the data. We see that there are 150 observations with 4 features. This sepal, this, right? These are called features, right? We said these are features. There are no null values. The data set is complete, which is not the case if you have data. Sometimes we have null, and there are 50 observations for each class. We'll see that in a bit. So let me ask a question. Is this example problem that we are trying to solve, is this classification or regression?
It should be classification.
Yes, it's called classification. Yep, that's right. Now, now we have we have seen the steps, 2 steps. We say what we have in machine learning. We have the first one, which we said is this the class machine learning project. What are them? We have no. Okay, machine learning project. We said the first one, classify problem, right? We have seen the problems which are from the problem. Number 2, get the data. Now we have understand the problem and we get the data. Now the next thing is process the data. So let's go on and see what is the meaning of how can we process the data. This is the processing the data. All right, let's process the data. Oh, now when you want to process the data, what does that mean? So machine learning has several steps, as I said, but they are not this thing you said that it should be this way. The first thing when you get your data is what is called data exploration or data understanding. Now you frame the problem, you obtain your data. Now, when you obtain the data, try to understand what is this data? How does this data looks like? Does it have missing values? Are they categorical variables? Are they continuous variables? What are they? So this is why we said, once you get your hands on the data for the first time, you want to know its structure. For example, how many number of columns does it have? How many number of rows? Understand how they related to each other and whether something looks unusual. Try to find out if there anything unusual. For example, maybe you can get a data set and you don't know that the first column, only the first 100 data are available, but all the last column, all the last row, the data is empty. So you try to do kind of looking at the data and see what is this kind of looking at your data, doing some kind of preliminary analysis, trying to understand the data is called exploratory data analysis, or EDA. Yeah, exploratory. You are trying to explore data analysis. So while trying to understand the data, do data isolation, there are many things you can do. Number one is we can do visualize the data, and you can also, if data is having some missing value. If your data is having some missing value, how can you deal with the missing value? We will discuss this in details. I'm just giving the step, but don't bother if we don't know. Data may have unnecessary column. So for example, you may have your data set, maybe this is a data set, and for example, you may have a column here called serial number. And this serial number, because this column, Pandas put this column for us automatically. But we may have a column here called serial number, which indicate this is number one, what is it called? Number one, first flower. This is the second flower. This is the third flower, serial number. So you can see serial number column. Do you think we can take this serial number column as part of our predictors in training machine learning model?
No, at all.
No, at all, because serial number is not part of the data. Is that right? It's just something that shows that count for counting our observation. Is that correct? So in that case, if you have in that case, if you have column for serial number, which will not affect the data in any way, you see, column for serial number will not affect the data trying to whether it is particular over. Then we can drop that column. So there are many things that you can do with the data. You need to understand. That time you have some unnecessary column like serial number, which is unique for each user. So we may delete the column if it's not required in our analysis, because the serial number column will be unique for each user, because 1, 2, 3, 4, 5 up to 10. It's not something that machine can learn. Do you understand what I mean? So there are a lot of things that we can understand. This is this data is on its own is something that we need to learn. Exploratory data analysis, and this exploratory data analysis is done maybe using Pandas library. You can do a lot. That is why we learned Pandas in previous session. We can do what is called scaling, balance the amount of data for each result. So sometimes you may have this one. You may see, okay, I have 3 classes. What are the classes? Setosa, Vesicular, Vagina. Now, what if Setosa in your data set you have 150 and the Setosa is 130, Vesicular is only 10, Vaginica is only 10. Therefore, we have 150. So you can see, is this equal classes or not?
They are not equal.
They are not equal. What I'm trying to say is that, for example, I have this, my flower 150, but 130 out of 140 are all Setosas. Only 10 are vesicular and only 10 are vaginica. Here you do not see vesicular because it's somewhere else, because this is not the complete, this is 150. Now the problem, what I'm saying is that when you are given a data set and you say, okay, I'm given 150 data set, I want to train machine learning model. But when you look at the predictors, the class, you see, out of that 150, 130 are single class, while the other 2 classes are 10-10. You say, it means there is no even classes. And machine learning learn best when you have equal classes, even. So this means that you need some ways in which you can actually, you can tell the person who gave you the data, this data set is not actually even. Can we get an even data set that with the machine learning? So these are some of the things you need to look at your data. That's balance the amount of data we have for each result class, so that it is signal at the learning may be biased toward a type of result, and your model try to generate knowledge will fail. So if we have like 130, then the model will only learn to classify Setosa very well. The model will not understand how to classify virginica and vesicular, because there are only 10 examples in each. You understand what I mean? So in this sense, the model will understand poorly. If you want the model to understand, to generalize well, then we give it equal classes. So this is what you call data exploration or data understanding. We will discuss a lot of that. Don't just get confused. We are doing a lot. This today, as I said, this is for us just to try to see the big picture of machine learning. What we have seen, the first one is frame your problem. The second thing we have seen is get your data. We have our data. How can you get your data? We said, okay, you can create your data set, or you can get it from Google, from any other sources. The next one we said is process the data. But the processing the data involves 2 steps. The first one is exploratory data analysis. Try to explore your data, understand the data. That is what we have done. The second step is prepare your data. So now we have seen exploratory. How can you do exploratory data? The first one is, okay, let's look at our data set. Here, this function, as we have seen the head function, the head give us, let me give this one. When I have this iris here, give me the head of the data, the first 5 of the data. So I can see, oh, okay, this is the data set. All right, I have. Now you can also see the tail of the data. The tail of the data is the last 5 of the data, last 5. So you can say, oh, okay, right, okay, this is, you can see this, okay, this is the last 5 of the data. So you understand, so we are trying. Now, you can say, okay, so now how many observations? Because when someone gives you the data, you don't know how many do you have. So you say, okay, how many observations do I have in this data set? So you can do that using the length function here. We have discussed this using Pandas here already. So the length, the name of the data set is iris. When we say length, it gives you the length of the how many rows you have. So we have 150 data observation. But you can do, there are many ways you can find the length of the data set. Added the shape 0, this will give you the shape of the index, which is also the same as 150. But we can also this one length, that index 0 means the index, but the index also will give you 150. So you may see this different variety of this, how to find the length of the rows. So these are all ways you can find how many rows you have in a data set. These are all pandas. So if you that is why I gave we went through some pandas learning, and I'll also share a Kaggle notebook on how you can get up to speed with pandas. If you want to get up to speed with pandas, just ask in the channel. I will share the Kaggle. I think this is what I shared. Kaggle. So this Kaggle is a good way for you if you don't have time to go through to learn some stuff very quickly. So this is pandas, how you can start learning pandas. So pandas is how you can do read files. You can see now we use read CSV to read file in our to read our data set. So here, for example, if you come here, you would understand. For example, they will teach you how to read CSV. If you create CSV, you create data frame. Yeah, right. Okay, a lot of stuff which we have already discussed. So how can you read a file? You can see pandas read CSV. A lot of things you can learn from here. Not only that, there are a lot of stuff that you can do. How you can do indexing, summary, functions, how you can do data type of missing. So these pandas, for example, if you are data, when you are doing data exploration, you have missing data, we will use pandas to actually use some stuff. So this is good if you, some of us here, they have already finished this course. When you register in Kaggle, you can register in Kaggle and finish this, you will get the certificate of learning pandas. So I urge, if you have not followed us in the previous session, you can do that. Not only pandas, I think Kaggle, they also have, I don't know whether they have NumPy. NumPy, do they have NumPy tutorial? Okay, this is someone's notebook here. So even if you don't have, you have not follow us, you can also Google some kind of, I will share it. This is NumPy tutorial. Yep. So let's go on, continue with our discussion. So now we understand we have, okay, someone, Zaradin has question. Go on, Zaradin.
Okay, so with regards to Kaggle courses, yes, NumPy was under Python course. Okay. NumPy was under, it is not, they don't have separate course.
It's under NumPy. Python?
It is under Python, exactly.
Okay, so Kaggle has Python, learn Python. So let's look at it.
Yeah,
So
they
you can
have
see
Pandas separate, but NumPy is under Python class.
Okay, right. Thank you. So you can see this is a quick introduction to Python, which is 5 hours. Can you see? You learn a lot. List, loop, list comprehension, working with external libraries. I think this one is working with external libraries. That is where they introduce the NumPy possibly. So when you go here, you get some kind of so yep. Yeah, I think this is where they introduce NumPy. But we all discuss working with external library. We discussed this in our Python import mal, how you can import a lot of stuff. We discussed this one. So I will share this one for people if they are interested. They can. So that is why we take time trying to understand the Python basic so that when we come here, we just move on. So yeah, now we have understand, okay, we have 50 observations. Now, how many predictors do you have? So when you are given the data, maybe you have predictors 120 because these predictors are only 4. That is why we can see it with our eyes. Just we have 4 columns. This is it. But sometimes you can have 150 predictors and you select this one. So you can see, you cannot just see it. So you can find it. How can you find the number of predictors you have? So here we say iris.columns. This will give you the columns you have in your data. So you have sepal length column and we have class, right? So you can see that this gives you the column of your Pandas data frame. But yeah, so you can see here, we can say, okay, how many do we have here? We have 5 columns, but we can see that the last one is not predictor, right? The last one is target, right? So we have 4 predictors, -1, 5, -1. So yeah, we have 5 predictors. Okay. And then you can ask also, how many target output do we have? Right. So now here you can see how many target do we have. Now you have this class, this is a target. You want to predict how many, so here you can see we have like Virginica. I don't know how many target do we have. So I can follow this one and see, okay, how many target do you have? Iris, when you have the column, here I have this iris, it gives me all the number of columns, but I don't want to see the number of columns. I want to see unique columns, unique setosa. How many setosa do I have? How many unique variables? So I can use this one, iris class.value count. It will count the unique. So it means I have iris setosa 50, I have iris vesicula 50, I have iris virginica 50. So you can see this class is equal, right? It's distributed equal. So this is just what we call data exploration. We are trying to look at the data, but you can also do one function in Pandas, which is called info. Pandas allows you, gives you a function called info to get information about your data set. So you can see it telling you that how many interests do you have? You have one range index, you have 150 rows, right? Instead for me to do the first one that I say, okay, how many rows do I have where I use this one? Length of the iris data set, I have 50. When you use info, this one will give you automatically, okay, I have 150 interests and I have number of columns, and it can give you the columns. How many columns do you have? You can sepal length, sepal width, sepal this, you have class. Okay, you can see these are the predictors for, and this is the target. It will tell you that, okay, null count. So it tells you that each one is 150. Each one is all sepal length, we have 150, and there is no null. Class, we have 150. What does that mean? We have 150, of course, because if you look at our data, sepal length, we have interest 100 from 1 to 50. Sepal width, we have from 1 to 50. Sepal fatal, we have, and class, we have 1 to 50. So each one we have 1 to 50. So this info will give you such kind of info automatically. Yeah, so we are still just exploring the data, but there are many ways to explore the data. This is just a tip of ice. There is another function called describe. It will give you some statistics about your data. For example, count. How many sepal you have? 150. What is the mean? What is the standard deviation? What is the maximum value in sepal length? What is the minimum value in sepal length? What is the quartile of 75 count? So this has a lot of things you can do. Now, after you inspect your data, you can, the next thing while doing data exploration is to visualize your data. Inspecting your data is a good way to find abnormalities. Maybe some of your arising measure, your inches or not. So for example, the example we see, all our data is measured in centimeters. But when you try to explore your data, you may find that, this one is measured in inches, no centimeter. So you can correct that. But one of the best way to inspect data is to visualize the data. That is it. One of the best way to inspect the data is to be there. One way to do this is by using scatter plot. So we know what is scatter plot, right? Scatter plot. Do you all know scatter plot? Scatter plot. So this is a scatter plot. This is a scatter plot. So this is a scatter plot. Can you see a scatter plot? This plot is called scatter plot. So if you are doing machine learning and you have two variables, for example, fail and pass, you can plot scatter plot and look at the, so this one you can see that this variable, they have, as this guy increases, the, what is it, the height increase. As diameter increase, right? When the diameter is 4, you can see the height is, when the diameter is 6, you can see the height is, when the diameter is 8, you can see, so you can see there is a relationship between diameter and the height. So this kind of observation tells you if there is any relationship of your data. So that's why they say one of the best way to do experimental analysis is to visualize your data. So we want to use a Seaborn, which is Python visualization on top of Matplotlib. Let's look at Seaborn Python. So you can see this is a Seaborn, which is Python packet for data visualization. So we use it here to visualize our data. This is Iris. Can you see? This is how you can do. You can find out how that. So let's visualize our data and see what happens. So here we import. We all know what is the meaning of import, right? Import Seaborn as SNS. We learn this one, how we can import. Then we create an object SNS, set palette this, then we call this SNS pair plot. So we are using pair plot. Why? Because one of the best way, as we said, to if you have two variable, is to use scatter plot. But our variable here we have 4 predictors. Which one and which? We have sepal length. We want to find the relationship between these predictors. Sepal length, this one, we have 4. So when you have 4 predictors, you cannot use scatter plot. So we want to use what is called pair plot, and this pair plot will show us some kind of relationship. We use it for more than 2 predictors. When you have more than 2 data points, you can use. Yeah. So here we said one of the best way to inspect is to be like, one way to do this is using scatter plot. A scatter plot of the data put one feature along another along and draw a dot for each point. But here, unfortunately, computers can have only 2 dimensions, which allow us to plot only 2 features at a time. It is difficult to plot data set with more than 3 features this way. One way around the problem is to plot pair plot, which is this pair. Can you see the plot we are doing? So this is a data set, which is pair plot. So you can see what we are trying to do is classification. You can see, oh, this we can do. You can see this is, which data is this? You can see it's Virginica. So here we have Virginica, between Virginica and which one is this, Setosa. You can see, yes, we can classify this one. You can see, we can draw something line like this. We can say anything below this point is, which one, Setosa. Any point below this is what? Which one is the Virginica. So you can see there is data, your data shows you, yes, of course you can do classification, right? So for example, sepal length and petal length, you can see the relationship. Yes, here you can do classification, you can classify. Can you see that? Where you have this kind of thing is sepal length, sepal width with sepal width for the same data, but different data. So this is one thing we learn. We'll learn a lot about this, but now the basic things you should know is that, yes, of course, after we float our data, we can see, oh yes, our data set is somehow separated. We can do separation. We can put a line here. We can put a line. That is what we will use. We use what is called KN neighbors to put a line to separate this. So we'll classify this data set. Right. So we can see from the plot, we can see that the 3 classes seem to be relatively well separated using a sepal and petal measurement. This means that a machine model will likely be able to learn to separate them. So yeah. So this is how we can do that. So we see this thing. This step we have seen is what we call the 3rd step is to understand your data. And understanding your data is to do some kind of exploratory data analysis and also visualize the data. But under processing the data, when you explore the data, understand the data, the next thing is to do is to prepare the data. Now, we have data which is 150. We cannot train the whole machine learning with this 150. We need to prepare the data to create what is called training set and test set. So here we say we cannot use the data we used to build a model to evaluate it. This is because our model can always simply remember the whole training set. The motion, the same example I gave for doing exams with your student. When you have a student, you learn them 1 + 1 is 2. You cannot also evaluate him on 1 + 1. So to evaluate model performance, what we need to do, we show it new data, what we have not trained it on. This is usually done by splitting the level data. So how can we do our data? So when we have our data set, which is 150, correct? From here to here. What we can do is, okay, we say, all right, what we need to do is separate the data from 1 to 130, from 1 to maybe 145. We use all this data set for training. For 145 to this number, we use this for evaluation. So when we train our model in this set, the first one, we train the model, we finish, then we come and test on this one. So we said, okay, we train the model using this data. Then we give the model and say, okay, this is sepal length of particular flower. This is a sepal width of particular flower. This is a petal width of particular. This is a, tell me which flower is this. Then if the machine learning, the model learn very well, then the machine learning will tell you this is Bejonica. Again, when you give it, because you have not trained on this data, when you give the machine learning, okay, I have a new data. Tell me which class is it. So you give the machine learning model. You say, okay, the sepal length is this, the sepal width is this, the petal length is this, the petal width is this. Tell me which flower it is. If the machine learning learn a lot, he can do good thing. He can, this is Bejonica. But if he does not learn, of course, it's not always 100%. You say, okay, Sky. He may not learn. He hasn't learned very well. So that is the essence. We said this one processing. Dividing the data. That is how to assess the model performance. So assessing the model performance is using on test set. Training the model is on training set. Assessing the model performance is what is called in training set or training set. Training data or training set. But assessing the model performance is called in test data, test set, or hold out set. This is another terminology. Just remember this thing. Hold out test, test set, test data. That is where you evaluate your model performance. Where you do your training for your model is training data or training set. How can we divide our data? So any question before you continue? I'm just making noise a lot. Any question? Ask question before we continue. No question? Okay, let's continue. If there is no question, we can continue. Right, Bilikisu, there is no question?
No question, sir.
Right, okay. So now we have seen now to process the data, the first thing is to do data exploration, to understand your data. When you understand the data, then you divide the data. Divide it into train set and test set. But how can you divide your data? So now I have my data set 150. How can I divide it? Can I take 150 to be training, 50 to be test set? Or do I need to divide them into equal? 75 for training, 75 for test data. Who can give us an answer? How can we divide the data? How can we divide the data? Do we divide it equally?
No.
So how can we do? How can we do that?
Training set should be more than
train test module or something like that.
Okay, right. Zaradin, tell us. Zaradin, go on, Zaradin.
So we normally divide our set into two sets. Basically, we normally divide our data into train test and train set and training set and test sets.
Okay, right. But how do we divide? Do we divide equal? For example, if we have 150, we divide 75 by or 75. Training set to be 75. Test set to be 75. Is that correct? Is that how we do?
No, most of the time we divide our the training set contains the large portion of the data.
Okay.
While the test set may contain like 30 or 20% of the data.
Okay, correct. Okay, good. So Zaradin tell us that if you, for example, we have 150 training data set, what we can do to create a train set, he said, will be contain the large part. So the large part here, for example, 120, and the test set will be 30. So this is it. When you have a data set, the large part of the data should be for training set. The small part should be for the test set. But one of the rule of thumb that people do is to have 75% of your data to be training set, 25% of your data to be a test set. This is a rule of thumb, but it's not like something that is necessary. Fortunately, do we understand? So, yep. Fortunately, we may not only sometimes we cannot say, okay, from 1 to 175, I take the data set in sequence. So sometimes there is what is called this in shuffle. So here, just let me give you an example here. Now I want to train my machine learning model. Now, from 0 to 50 here is Setosa. From 50 to 100 is vesicular. From 100 to 150 is Virginica. Now, when I want to take 75%, for example, then I take, for example, from 0 to 1, maybe 120. From 0 to 120, when I take it, then the training set contain Setosa. From the first 50, contain the second 50, which is what is it called? Not Setosa, vesicular. And it contains only 20 Virginica. Therefore, the test set contain only how many? 30 Virginica. Do you think the machine learning model will make a good prediction on test set?
No.
Okay, so this is the idea. Before we do our dividing of the splitting our data set, we do what is called shuffling. Mun gane abin da ake nufi da shuffling ko?
Yes.
Eh?
Yeah. Yes, sir.
Yeah, we do shuffling. What we mean by shuffling, this data, we shuffle it. Mahargitsata. It means we shuffle it. It means the data set will be like sinchakudu. Do you understand? But it means when we have now 120, it means we will have all the representative of the classes. We have Setosa, Virginica, and we have in the last we have the representative. So that's what is called shuffling, random shuffling. So in some sense, you can even divide the data set. For example, you say, okay, take 30 from Setosa, take 30 from Virginica, 30 from vesicular. You can do all these. There is different strategy to divide your data set. So I'm just giving you an example that we don't just divide our data set just like that. There is an idea how you can do that. So one good thing is that scikit-learn, the packet that we'll use for doing machine learning, comes with a good way to divide your data set. Let's look at sklearn, scikit-learn train sets, train split. Right. So scikit-learn comes with function that allow you to split your data. Scikit-learn model from model selection, train, test, split. It divides the data into train and test and split it into classes. Now let's look at what we mean. Let's see an example. So here I give an example on how we can the notion of building splitting our data set. So let's create a hypothetical data and show how we divide our data set. Now here I create a data for import numpy as NP. We do from scikit-learn import train set split. So when you want to do your scikit-learn, we already know that train set split is a function under model is stuff under a model selection. So we import this one. This is what we already learned. Now, who can tell me what I'm doing here? Who can tell me what I'm doing here? This Python code, who can tell me?
We are creating a 5x2 array.
Okay, and assign it to what?
Assign it to X.
Okay, and assign it.
Yes, and
what of Y?
Y, it's simply an array of 0 to 5.
Exactly. So this is what we learn in. Exactly. This is what we learned in our NumPy, if you remember. So this is this single code. It's meaning that because here I put comma, it's the same as this. I'm creating a data set. It's the same as the np.arrange create a data set of a range of 10, but reshape it into 5 by 2, right? And here create a single number range from 1 to 5 and assign to y. So I'm creating two. This is the same in Python. If you want to do multiple assignment, you divide by comma. It means the first one here, the result will be assigned to x. The last one, range of 5, will be assigned to y. So this is still the same thing. I just this is how it. So I just want to give an example how you can do divide, transet, and split from scikit-learn. You import this. Now I create what is called S. Let's look at what is X that I created. I create just hypothetical. When I say hypothetical, some example. So you can see this is 5 by 2. I create how many data? 10 point, but I reshape it to be into 5 by 2. That is 5, 1, 2, 3, 4, 5. So we can say I have 5 by 2 column. And this is a range Y, which is just a single number. But when I say I call range, you can see it gives me a range is 0 to 5. That is, well, yeah, 0 to 5, right? But for me to see the numbers, I can call a list on it. You can see this is 0, 1, 2, 3, 4, right? This is our value of Y. Now, what I want to say is this: how transet and testset works. This is how transet and set work, the function. You said train, test, split. You give it a data set. The text size, the train size, the random step, and shuffle if you want the data set to be shuffled, and do stratify if you want. Let me go into this one by one. What is the meaning of array? It means array sequence of indexes with the same length. So here what I'm trying to do is, for example, I have my training data and I have my test data. This is just a simple, because you can see here I have 5 rows, right? And here is 5 also. So these arrays that you put, they must have the same number. So if I want to put the training size, training data, they must be of equal length. So let's assume our X is training data, Y is test data. Now this is what you put there for array is X. So here you can see I want to do the function. I call the function train test split. I put X, which is train data. I put Y, which is test evaluation test data. Can you see that? So now for you to call this function train test split, which divide your data, you put something here in machine learning. We said we use capital X for training data. So you can see we have X train, X test for your training data. So for training data, you have training data, you have test data, and also for your test data, you have Y train and you have Y test. So what we can see here is this. You said, okay, what is the test size? We want to divide our data set into 2, test size and train size. So the test size, what is the meaning of test size? If you look at this one, test size, you can input 2 things, either a floating point number or an integer, or default. What do you mean by floating point number? So if you put a number between 0.0 to 0.1, which is float, it must be between this range. What this means, if I say, okay, test size should be 0.5 or it should be 0.7, it means the test size should be 70% of the data. If you use floating point, the test size you want to divide should be, now if we said the test size is 0.7, what will be now the train size?
0.3.
0.3.
It will be 0.3.
Yes.
So that is why here you said test size should be float or integer. So if you don't want to use float, then you say, okay, the test size should be 70. I mean, if the data is 100%, if the data is 100, then you say, and you want 70, you said, for example, 70. If the data is 100 and you want 70%, you want 70 of it, you say 70. But if you don't want, put an integer, you can put 0.7. So you can, whenever you see floating point, you can use floating point or integer. So also, when we have this one, which is train size, for example, which is 0.7. Okay, no, 0.3, for example, train size is 0.3. What will be the train size will be 0.7 automatically. Is that correct?
Yes.
Now, so in this case, you don't need to put training size in some cases. If you provide the test size, you have your data size, data set, which is 150. And you say, okay, take 30% to be test size. What will be now the train size?
70%.
70. So you may not necessarily put the test size. The cycle line will automatically or configure the training size. Else, if you put the train size to be 0.7, you don't need again to put the test size. Scikit-learn will automatically configure your test size to be 0.3. So we don't need to say test size equals to 0.3. We don't need to specify this. Scikit-learn will specify this one for us automatically. Now, the random state, this random state allow us to put a random state for creating the test set and test set, training set and test set, so that whenever we come back, we have the same thing. But also we have many parameters. Shuffle, when you say shuffle is true or false, when you say, okay, shuffle is true, it means you are shuffling the data before you do division. As I gave an example previously, we want to shuffle the data set in some sense. If you don't shuffle, sometimes it may create a problem for you that you have some other classes in some stuff like that. So this is some of the parameters. There are a lot of other parameters, but just here, what is happening? Go back. Okay, right. So we have another parameter here, stratify. We will look at that later. We have splitting. Now, the splitting, what will it return? So we want to split our data sets. Now, just remember what we are doing. We create, for example, training size. This is the training size, our training size. This is just hypothetical. We come to the, this is a test side. Why? We have 0 to 5. Now we want to create, split the data. We call this train test split function from scikit-learn. And we have X train, X test, Y train, Y test. When you call this function, when we run this, now scikit-learn has divided our data set. The test size now is 0.3, train set is 0.7. You can see this one, 0.7 must be, this is not correct. They have different percentage. So here I can delete this one, because they must sum up to 1. So here I create a test size to be 0.3, and I create the automatically the training size will be what? Will be 0.7. Now let's look at it. What is X train? Who can tell me now? What is X train? What is the size of X train? Because our data science is how many data train data we have first? We have 5. But we said, okay, the test size should be 0.3. What will be the X train?
0.1.
Eh? Okay, so yeah, you can see the 0.3, 30% of the data for 5 is 3. You can see this is the train set, and this is the X test. You can see scikit-learn has already divided our data set. X train, Y train. Can you see the Y train? This is a Y test as well. It's already divided our data set. So this is how scikit-learn divide our data set. This is just an example. So let me go back to our real data and see what will happen. Now let's look at our data. Okay. Now, how can you? Sir. Yes, go on.
Sir, I need more explanation on this XY trend and test.
Yes.
Why
okay.
do we have 2 values?
Yes. Okay. Let me come and explain from my data set. Okay. Let's look at this. Please ask question if you have question. Let's look at our data. Iris, just head. Okay, can we see our data?
Yes.
Okay, now what do we want to do now? Who can tell us? We are trying to divide our data into what? Into 2. Training and what?
Test.
Okay, good. Now, but remember, when we want to divide our data into training and test, we have many things in it.
We have the feature part and we have the level part.
Yes, yes. Can you see my screen? Hello?
Yes.
Yes, sir.
Okay, yes, okay, yes. We have, yes, yes. We have many FAT. We have what is called the future FAT, right? Which is our futures. And we have this FAT. This FAT is called what? Hello? Can you hear me?
Yes.
We can hear you, sir, but your cursor is not moving.
Okay.
So we can't.
So we have what is called. Okay. Can you hear me now? Can you hear me now?
Yes, we can hear you.
Yeah.
Hello. Okay. Okay. Now, someone asks, why do we have X train, X test, Y train, Y test? This is what I want to explain. I think this is a very good point to listen and understand what we mean by that. Now, we have our data set. This is the data set. And we want to divide this data into two. Just give me an example. We want to divide it. Okay, let's assume the training set is from 0. This is a training set. Just assume this is a training set. And this test set, validation set, we said is from here. Now, it means for the training set, we have two classes. The first class is X train. What we mean by X train is this. We call X in scikit-learn as your futures. These are called X. All these one are called X. While the predicted class is called Y. So it means when I divide my data set into this will be the training. It means I have X train. All these values are called X train. And I have what? Y train. Do you understand what I mean? So here I have this. I will have X train. And I will have what is called Y train. Now, in scikit-learn, capital letter X is used for training to represent training set. Oh, please go back. Excuse me. No, what happened? Okay, excuse me. Let me. I think something goes wrong. Okay. Okay, let me.
You overwrite the values of Y.
Yeah, I override it. I override it. So let me create it again. Iris. That head. This is a good. This is something. Please be patient. Let's understand this. This is very critical to the understanding. So let me show it what I mean. So if you don't understand, please raise a question. If you understand, this is a good step for us to understand. So this is what I mean here. I said what the step we are here is to divide our data set into train set and what? Test set. The training set will be used to train our machine learning. The test will be used to evaluate our machine learning. Now, let's assume this is our data set, which is from 0 to 5. 1, 2, 3, 4, 5. How many data? We have 5, right? So we say, okay, we want to divide our machine learning, our data sets into 3. From 1 to 3 will be used for training data, right? And this one, the last 2 will be for test data. But in scikit-learn, we have the notion X, capital X, represent training data. When the not trained data, what do you call it? Futures. What are these called? What are these called? Sepal, all of this one. Who can tell us what are these called? Eh?
They are the features.
They are the features. The features.
Or what?
That describe each.
Iris. Or predictors.
Or predictors, exactly.
Or predictors.
So this is so in scikit-learn, capital X is used for this. We have Y in scikit-learn, not capital X, not capital. We have Y, small y, is used for. What is the name of this one? This column?
It's called level. Okay.
Level, exactly. Yeah, we call it level, or we call it what?
Target.
Class, or we call
Class
it what?
target.
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 Right.
Yes.
Okay.
Mm.
So
Target
it
or
means,
predicted.
okay, so it means here, if we divide our data sets into training set, I have X train, capital X, which is the value here, this value for the training. All this value that we'll use for training are called X train. But we also have this target for the training will be called Y train. Do we understand X train and Y train now?
Yes.
Yes,
Now,
understood.
the last two that we will use for evaluation, the first one is called, who can tell us?
X test.
X test.
Exactly, it's called X test. The last two value is called what?
X
Y
test,
Y what?
Y test.
Y test. Then it means when I am dividing my data, I'm dividing my data into how many classes, how many groups, how many subset?
4.
How many subset? Who can tell us?
We need 4.
We are dividing into 4. Do you
Yes.
understand this? If you don't understand, raise your hand. Ask question.
It is
If you
clear,
don't
it is
understand this,
clear,
it will be
sir.
difficult. Eh?
It is clear, it's understood, Leskia.
So we have 4 subset of our data. So when we have our data set, we divide the data into 4. The first one is trained data, but the trained data has in scikit-learn where we use X to donate training part, and we use small y to donate the target part. So X train is for the trained set, Y train is for the classes for the train. So this is for this train, this is the corresponding. For this one, this is the corresponding. For X train, for this one, this is the corresponding Y train. For the X train, for this one, and we have the last one for the validation or evaluation is called X test. So for X test here, for this one, it is corresponding Y test is this. For this X test, it is corresponding Y test is this. This is how we divide our data. So that is what I did here. So in scikit-learn, what you need to do is provide X train. Can you see it? X train. All the X's, all for the training, all the X, provide the X test, then provide the Y train, then provide the Y text. In this order, then just call the function X train, because train comes first. Train, you do the train, then you call this X train test split, then you input the parameters inside. And the parameters inside, we as already mentioned, the parameters inside, we can put the test size, train size, random state, shuffle, you can shuffle. When we put the test size, it can be float point number or integer or default. None, it means none. What we mean by none is this. Can you see here, I put the test size. I didn't put the training size. The training size, it means it's automatically calculated since I put the test size. So you can read more about this one here. I share in the channel. Yes, I share, right. So that is why you see when we run this function on this. So what is the first thing? The first thing you put is the training. The second thing you put is Y. What is Y? The test. So you can see when you do this, then the X train, the value, you have 4 values, 1, X train, X test, and that. That is what we will do on our data set. So now let's look at our data set. This is what we have. Now, how can we grab this only column, which is test class? How can we grab only this for the futures? This is what we are going to do. So you can see this one. We said X, which is capital X, is equals to iris, the drop class axis. So what I'm doing here is I'm dropping this class, this column. I'm dropping this column from Pandas and taking only this futures, because I'm not interested in this, because I'm defining what X is. And we know what is X. X is, as we said, is these values only. These values only. This one's only for trainer. X. No here. Don't look at this one. Only these are the X, right? So I will take only this column. Oh, without this one, this value, this value, this value. So in Pandas, this is how you can drop a column. How can we drop a column? We said iris, which is a data set, the drop, provide the class, the column we want to drop, which is class. It's called class, right? Look at it. It's called class. Can you see? I want to drop this column, and it's in which axis? Axis 1. So when I run this, I will drop that, and let's look at what will happen when I run this. So I run this. I say, okay, give me this. Let's look at what is X. Let's look at what is X. Can you see? Sepal length, sepal width, petal length. Can you see I dropped that column? Now I dropped that column. Now I want to now grab only last column. This column, last one. I want to grab only this column. How can you do that in Pandas? So for you to do that as well is to say the data set, and you do this way. You put this open bracket and provide the name of the column, which is class. Now when I run this, what will be the value of Y? Let's look at it here. You can see now what is Y. I can see what is Y. Can you see the last column is Y? Any question before we continue? This is a good thing to understand. Any question before we continue?
I have a question, sir.
Yes.
Where we dropped class for X, what the axis? Why did we say axis is equal to 1? I don't understand the meaning of the axis there.
Right. Right. So this is Pandas. In Pandas, Pandas drop axis, drop column. So look at it. Look at Pandas. Now I have columns A, B, C, D, and I want to drop B and C. What you can do is to provide the column you want to drop, B and C, and say axis. Axis is telling you you are dropping column. 1 means column, 0 means row.
Okay, yes, you thought of CFR.
So this is what the meaning of axis. 0 or index. You can say index. Or index, 1 or column. You can say 1 or column. Different is whether to drop from the index, that is 0, or column is 1. So here, when we say that, here 1, it means, so here we can say not only 1, we can say column. Do you understand? You can say column, not 1. It will give you the same thing. Okay, Faiz asked question. Faiz ask you a question. So this is it. So you can see, you can say either 1, you can put either 1 or columns, or you can, if it is row. So that is why here, because we are trying to, that is why we put 1. Yeah, that is Pandas. You can, yeah, Faiz ask you a question.
Yes, it's really not a question, sir. Observation about
Yes.
the time of prayer. I don't know what time is
we supposed to finish at 35 minutes, but we are running out of time. So I think let's get something here, and we stop at building your first model. Right. So 5 minutes. So you can see here we drop our the last column. Here we have this. Now what we can do is we now split our data into test set and train set. So what can you do? Train, test, split, you call it. Input your X, which are all the column for the training. Can you see that? What is your X? Remember, our X is this, all these columns. The column, this one.
Features.
All the features. Exactly. All the future column. All the future column is what we put at the first. Can you see it? X. What is Y? All the what? The target column. Yeah, all the Y is target column. Can you see it? Now you put it here. But how can we divide the data? I put test size is equal to 0.4. It means I'm dividing the data 40% to be test size, 60% to be what?
Training.
Training. Then here I provide a random state, which is 5. Random state, you can provide any number. What is random state? If you look at the documentation, random state, integer. It can be any integer. Go on. Control the shuffling applied to the data before applying split. So it control the shuffling, pass an integer for reproducible output across multiple functions. So for reproducibility, when I do this shuffling, I do the division. Next time, if I run it, I will have the same division, the same thing. So if I run this one, let me close this. If I run this, I already now do the shuffling. I already did. So we have the train set and test set, everything. So here we can see print X train. We can see our, let me show us here. Yep. So we can see our here X train. Can you see we by our X train? How many are they X train? You can see from 60 to 99. Can you see to 99? Can you see that? So this is we do the division, and yeah, this is we can stop here. I think we will continue from building our model. So today in a recap, I will share this notebook. You can go through it even from the last part, building our model, how we can build the machine learning model. So to recap what we have done today, we have seen how we can do machine learning, the basic step to do machine learning. And the step to do machine learning, there are many steps, as we explained. There are many steps involved, but the general idea, we said it involves at least some steps here. And these are the steps. Frame the problem, get your data, process the data, and prepare the data. So we have stopped at processing the data, getting the data, processing the data. These two, we have done this very first 3. Next week, we will continue to model the data, how we can train our machine learning model, do the evaluation, and make prediction. Yes, any question before we go?
Yes, I think we need to talk more about feature engineering, because
yes, so, so
getting a good model depends on the feature selection.
Yes, so as I said, today, this is just giving us the whole idea what is machine learning is. This is the first chapter of the book, and it just gives you the whole idea, the machine learning step. The future engineering is one of the important parts that we'll see, and these are something that will be discussed. Future engineering is on its own separate chapter. We'll do that. Thank you for reminding us that. If you don't understand a lot, don't bother yourself. Just hear what we are trying to do is just to get a sense of what are the steps we do machine learning. We will take each of these steps and do it in details. Yes. Any question again? Right. So yeah. So next week, what we will do, we will continue from building your first machine learning model. We'll do evaluate the model and we'll make prediction. But before next week, I will urge you, all of us, because we are following this course, as I said previously, please read the book chapter 1. If for next week, read the book chapter 1, all the chapter 1, and also I expect you that to watch this lecture before next week from this website, from this college we are following. It will show you how to use Matplotlib, how to do visualization. So this is if you look at this one, you watch the video by the author of that book, and we will discuss if you have question from this part. Any question again?
Excuse me.
Yes, go on.
Can you please share the link of this website, this page you're on?
Okay. Yes, I share the link now.
Okay.
Any question again? Any question? Okay. I think I will upload the video, the recording. So for those that have come late, you will understand. But I urge you, if you want to understand a lot, read this book as well. Apply predictive modeling. I share with it. Read chapter 1 and 2. Read Introduction to Machine Learning chapter 1. before next week, you will have a good understanding what we have done. Yeah.
Sir, can you please
Directly
share the link? Please, can you share the link?
Which link?
Via our,
which link?
On our channel.
Which link?
On Slack channel. The link of the
I share
on our Slack channel.
Okay, I shared it.
Slack channel. Okay, so thank you.
Okay, I will share it. Yes. Any question again? So I think it is time for prayer. See you next week on Saturday. And please ask question if you have in the channel. As you go through, we will answer your question. Thank you.
Thank you, sir.
Yes, bye-bye.